What's up, guys? Recently I just started a fun project, which is that I want to see if I can write a program that automatically plays the minesweeper. So today I was just going to briefly talk about what I have done so far and all the steps that are involved in this project. So first of all, let me give a brief introduction to the minesweeper game. I believe most of people should already be familiar with the game, but in case you never played this game before, this is what the game interface looks like. In the beginning, you will have many tiles and you can open the tiles by click on it. Okay, so some tiles have numbers behind it, some tiles have mines behind it, and the purpose of the game is to open all the non-explosive tiles while identify all of the mines. The number tells you where the mines are located. So for example, if we have tile number 1, just means that there will be one and only one mine next to it. So in their adjacent 8 tiles, there will only be one mine, which is this one in this case. If we have number 3, then it tells us that there will be 3 and only 3 mines inside 8 of its adjacent tiles. So with this rule keep in mind, we can start playing the game. For example, if we're focusing on tile number 1 here, it tells us that among its 8 adjacent tiles, there should be only one and only one explosive tile. And because 7 out of the 8 tiles are already open, this tells us that this tile is an explosive tile, and we can identify it by right click on it. When we right click on a tile, a flag will show up, and this reminds us that this is an explosive tile. Now if we're focusing on this number 1 over here, because we already have an explosive tile within its 8 adjacent tiles, this tells us that all other tiles are not explosive tiles. So we can either open those 2 tiles by left click on it individually, or there's an easy way. We can press the right and left click together on this one, okay, and then it will open both for us. This trick will only work if you already have the number of flags next to your number. So right here, if I press both the right click and left click, nothing will happen because I don't have 2 flags among the number 2. And in fact, we only have 2 unrevealed tiles in this case. So this is just another example that shows us both of those 2 tiles are explosive tiles, and we can mark them by right click on it. Now this number 1 already has an explosive tile next to it, so it tells us that this tile must not be an explosive tile, so we can open that as well. So you can follow those rules, keep those rules in mind, then you can keep expanding your map. The goal to the game is to open up the entire map and then identify all the explosive tile. Once you do that, you will beat the game. So the number on the top left over here, right now it shows 88. That just tells us that there are still 88 mines that are unidentified. And then the number on the top right keep tracks of the time. So that's basically how you play the minesweeper game. So with that in mind, let's talk about what I did to write a program that automatically plays the game for me. Now let's talk about the high-level overview of the steps that are involved. So first of all, I need to download the Minesweeper game at this URL. I will paste the URL in the description below, so if you want to download it, you can also do it. Now, I didn't know how to hack into the game, so in order for me to convert the Minesweeper map into an array of numbers so that I can start writing my code, I actually took snapshots of the game interface and then using some image processing technique to convert the snapshots of the game interface or game window into an array and then start coding using those arrays as an input. So in order to take a snapshot, I need to know where the game window is located relatively to the screen. So I use the PyGetWindow library to do that. This library allows me to get the window size and the pixel positions of my Minesweeper game. And then I also use Pillow and OpenCV libraries to take snapshots of the game window and perform image processing. I use a software called paint.net to find the detailed pixel information within the game window. So paint.net is an imaging editing tools that allows you to zoom in and zoom out into pixel level, and it will also tell me the pixel position. So it's a very useful tool for me to use. And then after that, I need to write a function that converts these snapshots of the game window into a Numpy array. And then finally, I start to write a simple rule function that only considers one number tile at a time. I'll explain later what this simple rule function means. Finally, I use the PyAutoGUI library to move my cursor and perform the click action. So let's talk about the terminology and naming convention, number convention that I come up with. So whenever we have 0 through 8 number tiled, they will be number 0 through 8. Okay, and I call those tiles the number tiles. I number, so an unrevealed tile will be number 9. That's just me picking a random number. It doesn't have a specific meaning, but I need to assign this unrevealed tile a number, so I pick that as 9. And then I need to do some edge padding around the map. This edge padding will help me make my coding much easier. So the padding doesn't mean anything. I assign a number 10 to it. Whenever there's a flag, I assign to number 11. Okay, whenever there's an explosive tile, I assign it to number 12. And then whenever there's a stepped mine, that will be assigned number 13. So number 12 and number 13 shouldn't use very often. Whenever they show up, that also means the game is over. So that's the terminology and the number convention. So this is how I determined what's the size of each tile. So the size of each box each tile is 20 times 20 pixel. How do I know that? Because I can take a snapshot of the game window and I open the image with paint.net, and it tells me, okay, this pixel is located at 127. So by convention, the first number is the pixel position starting from the top left horizontally to the right. So the most top right position on your screen is always 0, 0. Or in this case, the top right position on my game window is 0, 0. 19 will be 19 pixels to the right of your top left pixel and then 127 pixel down. I can also get the pixel on the lower left of the tile. That's 38, 146. So doing some simple calculation, I can find out that okay, each tile is 20 times 20 pixel. I also need to know, okay, that's one tile, but I need to know what's the most lower right pixel of all the tiles, which is the pixel number here. I need to know, okay, depending on the game window size, this most lower right, bottom right pixel of all the tiles can change. But doing some calculation, I find out that the pixel position at the lowest right of these tiles is always at your width of the game window minus 20 and then your height of the game window minus 19. So every time I take a snapshot of my game window, I'll be extracting all the pixels from 19, 127 to the width of the window minus 20 and the height of window minus 19. That's the area that we are interested in. I also need to find out the pixel position of this smiley face, because this smiley face is how I determine whether the game is still in progress or it is already complete or I already lose. Because if the game is still in progress, it will show a smiley face. If I beat the game, the smiley face will start to wear sunglasses, and then if I step into a mine, the smiley face will become a dead face. The next step is, okay, after I take a snapshot of the game window, I need to find a way to convert it to a Numpy array that looks similar to the image below. So as I mentioned below, I pad my window with an edge padding that I assign to number 10. All the unrevealed tiles will be assigned number 9. Okay, and then if it's a number tile, it will just be 0 to 8, depending on what the number is. All the flag will be assigned to number 11. So this will be the input to our program, and then the output of the program is to determine the next step. Okay, it could either be a left click for a non-explosive tile or a right click to a non-explosive tile. So how do I do that? Well, I can do it using some simple image processing, because all images are still in a RGB channels. RGB is a red, green, and blue channels with intensity of each color ranging from 0 to 225. So just for example, this tile number 1, when I extract it, it can be converted into a 20 times 20. That's how many pixels we have, and then times 3. 3 is the RGB channel array. So I extract the blue channel, the green channel, and the red channel of this image. As you can see, within each pixel, the intensity for all channels are between 0 to 255. Now in the blue channel, the one in the middle will have a very high intensity, because indeed the number 1 over here is blue. It doesn't have any green color or red color, so the green channel intensity on this number 1 in the middle of the tile are all 0, mostly are all 0. Similarly, in the red channel, most of the tiles intensity in the middle of this number 1 are also 0. So with this information, I can do some image processing, and that tells me, okay, when I have a blue channel that looks like this, red channel that looks like this, green channel that looks like this, I'm having tile number 1. Okay, so I have another example for tile number 2. So tile number 2 is green color. Therefore, in the blue channel, this 2 has mostly 0 intensity. Similarly, on the red channel, it has mostly 0 intensity. But in the green channel, there's a high intensity in the number 2 over here. So with those information, I can distinguish between 0 through 8 for the number channel, and then also 9 for the unrevealed channel, and 11 for the flag as well. So using some simple image processing, I'll be able to convert this game window into a Numpy array that looks like the image below. Now I want to explain about the simple rule. So simple rule just means that I only consider one number tile at a time. So for example, in this first case, I already explained in the beginning of the video that this will be an explosive tile because among the 8 adjacent tile of this number 1 tile, there should only be one and only one explosive tile. And because this is the only one that's unrevealed, so this must be an explosive tile. Here's another example. So if we have a number 2, okay, and then we already know this one is an explosive tile, this one should also be an explosive tile because we need to have two explosive tile around the tile number 2. On the third cases, because this tile number 1 already has a explosive tile next to it, which means that 1, 2, 3, 4, 5, these 5 tiles are not explosive tiles. In the fourth cases, if we focus on this number 3, there's only 3 unrevealed tiles left, so all of them should be explosive tiles. Now by observing these 4 cases, we can come up with a simple rule. So for each number tile, check its 8 adjacent tiles. There will be 2 scenarios. Scenario 1 is within these 8 adjacent tiles, if the number of flags plus the number of unrevealed tiles equals to the number on our target number tile, then all unrevealed tiles are explosive tile. So case number 1 belongs to scenario 1. Okay, we have target number is 1, number of flag is 0, number of unrevealed tile is 1. So 1 is already equal to 0 plus 1, which means this unrevealed tile is a explosive tile. Case number 2 also belongs to scenario 1. We have 1 flag, 1 unrevealed tile, 1 plus 1 is 2. Okay, the target number is also 2. When those 2 number equals, that means the unrevealed tile is an explosive tile. Okay, similarly, case number 4 also belongs to scenario 1. Now for scenario 2 is when the number of flags equals to the number on our target number tile, then all unrevealed tiles are not explosive tiles. Case number 3 over here belongs to scenario 2 because we already have 1 flag and the number 1 is our target tile. So when the flag is equals to the number, all unrevealed tiles are not explosive tiles. So that's really the simple rule. Now with this rule, keep in mind we can start to write the program that automatically plays the game for us. Here is the pseudocode for the program. So first step is to initialize the game by randomly click on a unrevealed tile, because initially we don't have any number that provide any insight to the position of the explosive tile. So the best we can do is randomly click on a tile, and then while the game is in progress, we will play the game with simple rule until it can no longer identify any explosive or non-explosive tiles. When that happens, we will again randomly click on an unrevealed tile. And then this loop continues until either we lose the game or we beat the game. So that's the progress we've made so far. And you might be also wondering, if I have a simple rule, then there must be an advanced rule, and indeed you are correct. I haven't finished the advanced rule yet, but whenever we are talking about advanced rule, we will be considering more than one number tile at a time. So right now, simple rule, we only focusing on one number tile at a time. In the advanced rule, we will be considering 2 or 3 or 4 or above more tiles at the time. I will explain about the advanced rule in my upcoming videos, but right now I only have the simple rule programmed. So that's pretty much what I have done so far, and let's just see the result and see what's the winning rate of using just the simple rule. So finally we have a winning game. Out of 102 games, we beat the game once, so the estimated winning rate is about 1%. In the upcoming video, I will start coding the advanced rule and then see if we can improve the winning rate. Hope you like the video. If you like this video, please subscribe to my channel and give a thumbs up. I'll see you in the next video.